back. This is Ratio Lesson 2. Today we're going to tackle some really exciting challenges, combining ratios, solving word problems with bar models, and even exploring why area doesn't scale the same way as length. Let's dive in. It's sports day. The school tells us that teachers to students is 2 to 5 and teachers to parents is 2 to 3. Here's the challenge. Can you figure out the ratio of students to parents? Take a moment to think about it. Don't worry if it seems tricky. By the end of today's lesson, you'll be able to solve this in your sleep. The answer is students to parents equals 5 to 3. And the key skill we need is combining two separate ratios into one three-part ratio. That's exactly what Section A is all about. Section A, combining two ratios. Here's why combining ratios is tricky. We have Ken to Susie equals 2 to 3 and Ken to Ming equals 6 to 5. Ken appears in both ratios, but he has different values, 2 in the first and 6 in the second. So we can't just stick the numbers together. This is just like when you add fractions and need a common denominator. We need to make Ken's value the same in both ratios before we can combine them. The tool we use is the lowest common multiple, or LCM. Here is our four-step method for combining ratios. Step 1. Identify the shared quantity, the one that appears in both ratios. Step 2. Find the LCM of the shared quantity's two values. Step 3. Scale both ratios up so the shared value equals the LCM in both. Step 4. Combine everything into one three-part ratio. Let's see it in action. Example 1. Ken to Susie equals 2 to 3 and Ken to Ming equals 6 to 5. We want to find Ken to Susie to Ming. Step 1 and 2, the shared quantity is Ken. His values are 2 and 6. The LCM of 2 and 6 is 6. Step 3, scale the ratios. Ken to Susie is 2 to 3. Multiply by 3 to get 6 to 9. Ken to Ming is already 6 to 5, so multiply by 1. It stays as 6 to 5. Step 4, now Ken is 6 in both, so we combine Ken to Susie to Ming equals 6 to 9 to 5. Done. Example 2. Squares to triangles is 1 to 4, and squares to circles is 2 to 5. Find squares to triangles to circles. The shared quantity is squares. Values are 1 and 2. LCM is 2. Scale squares to triangles by multiplying by 2. We get 2 to 8. Squares to circles is already at 2, so it stays 2 to 5. Combining gives us squares to triangles to circles equals 2 to 8 to 5. Excellent. Here's a thought-provoking question. We now know squares to triangles to circles is 2 to 8 to 5. So what is triangles to circles? Think about it for a moment. The answer is 8 to 5. Once you have the three-part ratio, you can simply read off any two quantities. Triangles are 8 and circles are 5, so triangles to circles is 8 to 5. This is the power of combining ratios. Section B, shared quantity as the second or third term. Section B, example 1. J to K equals 5 to 6 and L to K equals 2 to 3. This time, the shared quantity, K, is the second term in both ratios. The method is exactly the same. K has values 6 and 3. LCM of 6 and 3 is 6. J to K stays as 5 to 6. For L to K, multiply 2 and 3 by 2 to get 4 to 6. K is 6 in both scaled ratios, so J is 5, L is 4, and K is 6. The answer is J to L to K equals 5 to 4 to 6. Example 2. P to Q equals 2 to 5, and R to Q equals 1 to 4. Find P to Q to R. Q has values 5 and 4. LCM of 5 and 4 is 20. Multiply P to Q by 4, get 8 to 20. Multiply R to Q by 5, get 5 to 20. Q is 20 in both, so P equals 8, Q equals 20, and R equals 5. Therefore, P to Q to R is 8 to 20 to 5. Notice Q is the largest. It's the most common quantity. Quiz 1. Test your skills. Quiz time. Spoons to forks is 4 to 5. The number of butter knives is 2/3 of the number of forks. Find spoons to forks to butter knives. 4 choices. Pause and try it before I show you the answer. Let's work through it. Since butter knives equals 2/3 of forks, the ratio knife to fork is 2 to 3. Now forks appear in both ratios with values 5 and 3. LCM of 5 and 3 is 15. Scale spoons to forks by 3. Get 12 to 15. Scale knife to fork by 5, get 10 to 15. The answer is C. Spoons to forks to butter knives equals 12 to 15 to 10. Well done if you got that. Section C, Fractions and Ratios. Section C is all about the connection between fractions and ratios. Here's the key rule. If A to B equals M to N, then A equals M over N times B, and B equals N over M times A. This is incredibly useful for solving word problems. Let's see some examples. If Layla has 1/2 as many stickers as City, then Layla to City equals 1 to 2. If Mike's marbles equal 3/5 of Sam's, then Mike to Sam is 3 to 5. And remember, Sam has 5/3 as many as Mike. The fraction flips when you swap who you're comparing. Here's a worked example. Pack A weighs 2 kilograms, Pack B weighs 5 kilograms, and Pack C weighs 10 kilograms. Look at the bar model. You can see how they compare visually. The combined ratio is A to B to C equals 2 to 5 to 10. Now we can express fractions easily. A is 2/5 of B, B is 1/2 of C, because 5 to 10 simplifies to 1 to 2. A is 1/5 of C, and flipping the ratio, C is 5 times A. See how the ratio and the fraction are two sides of the same coin. Section D, Word Problems with Bar Models. Type 1. Given the total, Anna and Jill share $50 in the ratio 2 to 3. How much does Jill get? Let's draw a bar model. Here's the bar model. Anna gets 2 units shown in blue. Jill gets 3 units shown in orange. Together, they have 5 units equaling $50, so 1 unit equals $10. Jill has 3 units, which is 3 times $10, equaling $30. Type 2. Given the difference, boys to girls is 7 to 4, and there are 12 more boys than girls. How many girls are there? The bar model shows 7 blue units for boys and 4 red units for girls. The difference is 7 minus 4, which is 3 units. The extra 3 units of boys represents 12 students, so 1 unit equals 4. Girls have 4 units, so girls equals 4 times 4, which is 16. Type 3. Given a fraction, Ken has 21 coins. This equals 3/7 of Hassan's coins. Find the total number of coins. Since Ken equals 3/7 of Hassan, the ratio Ken to Hassan is 3 to 7. In the bar model, Ken has 3 units equaling 21, so 1 unit equals 7. The total is 10 units, which is 10 times 7, equaling 70 coins. Quiz 2. Word Problem Challenge. Quiz 2. Adults to children is 3 to 2. The number of boys is 1/4 of the number of girls. There are 30 boys. Find the total number of people. Pause and give it a try. Here's the working. Boys to girls is 1 to 4. Boys equals 30, so girls equals 120. Children equals 30 plus 120, which is 150. Now adults to children is 3 to 2. 2 units equals 150, so 1 unit equals 75. Adults equals 3 times 75, which is 225. Total equals 225 plus 150, giving us 375 people. The answer is C, 375 people. Brilliant work if you got that. Section E, Harder multi-step problems. Problem 1. 1/3 of Lucy's coins equals 4/5 of Charlene's coins. Lucy has 28 more coins than Charlene. Find the number of Charlene's coins. This is a two-step problem. First, we find the ratio, then we use the difference. Step 1. We know 1/3 of Lucy equals 4/5 of Charlene. Rearranging, Lucy divided by Charlene equals 4/5 divided by 1/3, which is 4/5 times 3, equaling 12/5. So Lucy to Charlene is 12:5. Step 2. The difference in ratio values is 12 minus 5, which is 7 units. This equals 28 coins, so 1 unit equals 4. Charlene has 5 units, so Charlene has 5 times 4, which is 20 coins. Problem 2. Adults to boys is 3 to 2, and boys to girls is 1 to 4. There are 30 boys. Find the total number of people. First, combine the ratios. Boys appears in both. LCM of 2 and 1 is 2. Adults to boys stays as 3 to 2. Boys to girls multiply by 2, get 2 to 8. So adults to boys to girls is 3 to 2 to 8. Now, 2 units of boys equals 30, so 1 unit equals 15. Adults equals 3 times 15, which is 45. Girls equals 8 times 15, which is 120. Total equals 45 plus 30 plus 120, giving us 195. Section F, Thinking Aloud, Length versus Area. Section F, a thinking aloud question. Square A and square B have side lengths in the ratio 1 to 3. Is the area ratio also 1 to 3? What do you think? Let's find out. Here are our two squares. Square A has side length 1 unit, and square B has side length 3 units. You can see just how much bigger B is compared to A. Area of square A is 1 times 1 equals 1 square unit. Area of square B is 3 times 3 equals 9 square units. So the area ratio is 1 to 9, not 1 to 3. The area is 9 times bigger, not 3 times. Here's the key rule to remember. When length scales by k, area scales by k squared. So if length triples, area becomes 9 times larger. Real-life example. A pizza that is twice as wide has 4 times the area. So if you're sharing, size really does matter much more than it looks. Lesson wrap-up. 4 key skills. Let's wrap up. Today you mastered 4 key skills. Skill 1, combining 2 ratios by finding the LCM of the shared term and scaling both ratios. Skill 2, converting between fractions and ratios. A to B equals M to N means A is M over N times B. Skill 3, solving ratio word problems using bar models, whether you're given the total, the difference, or a fraction. And Skill 4, understanding that when length scales by k, area scales by k squared. You've done fantastic work today. Exit card. Check your understanding. Here's your exit card. 3 questions to check your understanding before you go. Question A. A to B is 1 to 2, and B to C is 3 to 4. Find A to B to C. Question B. Red to blue is 3 to 5. There are 40 more blue than red. Find the number of red. Question C. Nicholas weighs 5 quarters as much as Mindy, and Nicholas is 6.5 kilograms heavier. Find Mindy's weight. Pause and try all 3. Here are the answers. For A, B has values 2 and 3. LCM is 6. Scaling gives A to B to C equals 3 to 6 to 8. For B, the difference in ratio is 2 units equaling 40, so 1 unit equals 20. Red equals 3 times 20, which is 60. For C, Nicholas to Mindy is 5 to 4. The difference is 1 unit equaling 6.5 kilograms. Mindy equals 4 times 6.5, which is 26 kilograms. How did you do? That's everything for Lesson 2. In Lesson 3, we'll tackle ratio problems where quantities change after adding or removing items. These are some of the trickiest problems in the syllabus, and we'll have a really powerful method to crack them. Make sure you're solid on today's material before then. See you next time. Keep practicing, and remember, ratios are everywhere in